In this video, we're looking at choosing a sample size for a confidence interval. So last time we looked at this sample of lo-fi music listeners and we found a confidence interval and then we assessed a claim on this confidence interval. Now we're going to calculate the width of the confidence interval we found last time. So that was our confidence interval here. The width would be the top bound 0.687 minus the bottom bound 0.455. And that should roughly give us a number, hopefully. Okay, 687 take 0.455, so it's 0.232. Okay, so that's the width of the confidence interval there. Now, so with this, the researcher last time really wanted to make sure that more than 50% listened to lo-fi. That was their claim. Now, their confidence interval was just sort of too wide to make this claim, and it was very possible that P sat over here or up here, so we just couldn't decide whether their claim is true or not. So this confidence interval, it's got a width of, when you just work that out, 0.232. Basically, this lower bound here was 0.455, this number. So they reckon if they can pull it in a little bit more, so if they can pull the width into maybe like 13, then that may actually help them support the claim. That's what their thinking is. So we're going to determine the number of students needed for this. And there is a big formula for it. Here it is. 2 times 1.96 squared over W. And we got P star and 1 take P star. Okay, now P star is this new symbol that we haven't seen before. So P star is either your best guess at P hat or 0.5 if you don't know that. Now, in our case, we actually do have this guess at P hat because we already did a survey and we got P hat last time was 0.571. So for our purposes, we're going to use P star as being 0.571. If you don't know that, then you're just going to use 0.5. Now, I'd really encourage you to think about why this is true, but basically it's for the worst case scenario. So this little bit here is as big, well, it is maximized if P star was 0.5. So this is like the worst case. I'd really encourage you to think about why it is that P star being 0.5 gives you the biggest possible value for that whole bit there. Okay, but at any rate, we've got 0.571, so we'll just use that. So this is 2 times 1.96. The width they would like is 13%, so that's 0.13. We'll square that, and n is all that. So n roughly equals, and we'll chuck all that into a calculator and see what we get. Okay, so I've just typed that whole lot in, 222 or 223. Now you've always got to round up. So we need 223 students to be surveyed. Okay, the reason you round up is if you round down, your confidence interval will be a little bit too wide. If you had 222.7, first of all, that's impossible, but this would give you exactly a width of 13. And you just round up to make sure that width is less than 13. Okay, the researcher actually just surveys 250 students, so a lot more than what they needed, and finds that 137 of them listen to lo-fi. We need to calculate a new confidence interval. Now, this is technically from last video, but we'll just do it as a little recap. So interval, one prop, you got 137 and 250, and we get 0.486 to 0.61. 486. Okay, so that confidence interval is absolutely skinnier than last time. So this was our old confidence interval here. Our new confidence interval goes from 0.48 up to 0.61. And if the old confidence interval had its width being, I think it was 23, I'm hoping we can see that the new confidence interval width is a lot smaller. And in fact, our width there, in case you wanted to know exactly, 0.610 take 0.486, our width was 0.124. So our width was less than 13%. And that's partially because they used a lot more than 223 people. Okay, so width is 0.124. Really importantly though, we still can't accept the claim. So their claim was that the average was over 50%, but it is still possible that P could be there below 50% or P could be there above 50%. Now, again, I'd really encourage you to pause the video and try and figure out what went wrong. Based on our old example, we would have thought that having the width a lot smaller would have just made sure that we were over that claim value and we're fine. But in our case, it didn't. So pause, have a think about what went wrong. Now I'll tell you, P hat for this new survey has changed. So P hat there was 137 out of 250. And if we work that out, that's 0.548. By the way, another way to work that out if you want is you can actually look at your confidence interval and calculate the average, 0.6, and then halve it. You will also get 0.548. The old P hat was, where was it? 0.571. So with our old P hat, there it is. Apologies about my squish drawing. And then the P hat new is a little bit lower. And the effect that that has is it sort of shifts down the whole confidence interval. And this is something really important. Intuitively, as like a human, you sort of see a confidence interval. And at least this is how I feel about it. But I'm like, oh yeah, but P hat's really there. And if we just hand waved a bit, the confidence interval would be really small around P hat. That is not true because as you do a bigger survey, P hat may start moving around itself. Because if we could know what the actual proportion was, then we wouldn't even bother doing confidence intervals at all because we just know what P hat is. So P hat will move around as you do bigger surveys and you have to be very careful of that.